Hey everyone, welcome back to the channel. In this video, we are going to solve the daily problem of the lead code, the problem number 2211, count collision on a road. This problem is very interesting. It's based on an observation. Once you understand the observation that I'm gonna teach you in this video, then it will become super easy and interesting. So without any delay, let's move to the problem statement. What the problem is saying, you have given n cars on an infinitely long road. The cars are numbered from 0 to n minus 1 from left to right. Okay. You have given 0 index string direction of length n, or and direction of I can be either R, L, S, denoting whether the ith car is moving toward the right, left, or it's staying with its current position. And you have to count the number of collision, how many collision are occurring between them. And you have this also stating that the rules how to count the collision. When two cars moving in opposite direction means one is moving to the right and other is moving to the left, each with each other, the number of collision increase by two. It simply means if a car is moving to the R and other car is moving to the left, then the collision your collision is will increase by two. And if your car is when a car moving car collides with a stationary car, the number of collision increase by one. Means if a car is moving to the right and there was a stationary car, then your collision increase by one. So you have to return the total number of collision that are occurring between the cars. That's what you have to return. Okay. So tell me one thing. The car which are at the leftmost and moving toward the right, will it collide to something or some car? No, it won't collide with something because it is the rightmost and it moving to the right, and so it will not collide with the same thing. Same for this car. This is again moving to the left, and there's nothing on the left to collide with since it is moving to the left. And one more thing, every car is moving with the same speed. So if this is car moving with left and this car is moving to the left, so they won't collide anywhere. And the same for the this car, which is moving to the right and are at the rightmost, so it won't collide with anything. It will simply just wait a second. Let me open my brush. So it will simply move to the right. Okay. Same for this car, it will simply move to the right. The problem will start occurring when you encounter a car that is moving to the right and the other car that is moving to the left. That moment, you are granted that there will be a collision between them, even if there are cars between them or not, even if there are nothing in between them. So let's suppose there's nothing in between them. Okay. So even there are at least two cars that are moving in opposite direction. So they are bound to be collide at each other at some moment. The car will collide with the R to the left car, and this left car will collide to the R, even if there is nothing between them. Okay, since there is a car in between them, they are bound to collide with each other. Okay, so our problem will start occurring when we encounter something, not something where we encounter two cars that are moving in opposite direction. So our intuition will be the simple. We will eliminate or we will trim down the car that is moving to the left from the left side, and the same for the car that are moving to the right side from the right. Okay, what about, and one more thing, it has says that the cars that are moving in opposite direction, you will count them as a two. Isn't it same like this car is R is colliding to the left, and you got one collision, and the left car is colliding with the R, you got two collision. They are same, right? Let's take the example of this one. As per the example, it says you will count them as a one. So let's see. Suppose uh, the right car collide with a stationary car, you got one collision. But stationary car can't collide with the R. You know why? Because it's staying, it's not moving. So it can't collide with the one. So it can't collide with the one. So from here you got the one collision. Okay. From same for here, you got stationary will can't be able to collide with the left moving car, and the left moving car can be able to collide with the stationary car. So you got the one collision from here too. So how many collision you are getting isn't the numbers of the cars between them which are not stationary, because everything inside the range will gonna collide with each other. This R is gonna collide with this L. This L will gonna collide with R. This R will gonna collide with the S. This S can't be collide with anything. So until here we got three collision. This L will collide with S. So we got four collision. This L is again gonna collide with the S. So we got the five collision, and is the output is five. If we check this example, we trimmed the two L from here and two R from the rightmost. So we got nothing in between them. So there is not any car that's gonna collide with each other. So that's simply written a zero. Let's see this example where you trim down some L and some R from the corners. Or what if my there's not no any stationary car? So eventually they all gonna collide with each other. This L will collide with R. Again, this L will collide with R. You got two collision. This R will collide with this L, three collision. This with this four. This with this five. This with this six. We got the six collision, and it's the number of the cars between them, which is not the stationary, because stationary car don't gonna contribute. They are not colliding with anyone. They are not moving. The only moving car that are is left moving car and the right moving car. So I hope you got the intuition. Let's try to code it up. What do I need? I need the n less directions dot size. Okay, I'm writing a C++ code right now, but after that I will write a Java and Python code too. Then what we need? We need to trim down the left L. So let's create a variable left. Let's assign with a zero. What I need? I will start traversing in the direction until I got the one card that is not traveling to the left. So what I need? I will see my left, my direction of L. If this is equal to my L, I will keep moving. Okay, I will keep moving, and what I will do? I will just say keep left plus plus. Okay, this have to be left. I will simply say left plus plus. It means my left will start from here. This is left, so I move here. This is left, so I again move here. I got one value that is not pointing to the left, it is a right. So I will stop here. I have trimmed down these two cars that is moving to the left. But I need one more thing. What if there's all the left? So my left will keep traversing until it reaches here. That is the end. That is the end. So I have to check for this too. My left should be less than n, and direction of left. If this is equal to this, I will simply say I have to do the same thing for the from the right side. So I will simply say right GHT. right equals to 0, and I will copy the whole thing, just paste it here. What the heck? Controls. Okay, I paste it here. This will be my right, and my right should be greater than equal to 0. What if it went out of the direction? And this will be my right. This time I have to compare this with the R, because I have, and this will be right minus minus. Okay, I have trimmed out the trailing parts. Trim the trailing part, trailing R. Let's see R. Okay, and this is a trimming. I have trimmed the leading L. So what I need now, I need to count all cars that is not equal to L or R. That is not equal to S. Sorry, I have to count all the car which is equal to R or S, because they are the one who is going to collide with something. So again, I will go in the direction, and I will start traversing. From where? In the equals to from where? My start is pointing here, my left is pointing here, my right will be pointing here. So I will have to traverse between them. So my eye will start from left and go to the right. So let's say left I should be less than equal to right, and I plus plus. If my direction of I is not equal to S, I will simply say count plus plus. What is a count? I have to define the count to int cnt equal to 0. The number of collision is 0 at initially. Then after I have to return the count. I have returned the count. It should be working. Let's run it. It says a wrong answer. Why? If my direction of I is not equal to s of I. Okay. So this one is n minus 1. I hope you have seen before this. You have seen before me. Okay, so it's running because I am traversing from the end side. That's why. And let's move to the Java solution. Let's copy the whole thing. Let's copy the whole thing, because Java and C plus are almost same. What I need, I will copy paste it here, and there's not any bracket, so I have to write a dot caret, char at left, and same for here. It's a char dot caret right, RIGHT, and anything other, yeah, here. It's a caret dot caret I. Anything else? Let's run it. Direction dot size. Okay, it's the direction of length. length, length. It's running. Submit it up. Now let's move to the Python. Python 3. I'm using Python 3, and I would recommend you to use Python 3 because Python may be outdated. Not outdated. Maybe its version is old, but use the latest version. So let's paste the whole thing again. What is it int? What is it int? There's a lot to change, Let's, what is n? My n is length of direction. Again, there's not any int concept. There's not any. So let's just uh, left equals to 0, while it should be plus, it should be and, it should be left plus equals to 1. I hope I'm doing right everything. Please check out for the syntax error. This will be comment hashtag. This will be minus equals to 1, and this will be and. This should be count equals to 0. There's a lot to change. For int, there's not any syntax of. Let me write the whole thing. For I in range, from left till right plus 1. Okay, what I have to do? I have to do simply this. Plus equals to 1 if direction of I equals not equals to. I will simply return the count. I think everything is fine. Sorry, this should be. Now everything should be fine. I hope int count is equal to 0. Okay, intention. Int count equals to 0. Now you hope we should be learning. Unmatch, where is okay? Okay, it's running, and it will probably be summing up too. So I hope you understand the intuition behind this problem. This is a super easy problem once you understand the concept, or once you start observing the pattern. Whatever inside the collision range are bound to be collide with each other until they are not stationary object or stationary car. With this, I am wrapping up this video. I hope you like this video. If you like, to subscribe and like my YouTube or video. If you have some query or comment, to comment in the comment box. I will provide the uh, problem link into the description box, so you can jump directly from the to the problem from there.